Welcome back, guys. We are going to continue on with some more logic puzzles on the Brilliant app. So next up we have machines learning chess. So sometimes a choice can have undesirable results. When that happens, just be sure to not make the same mistake twice. This is logical, of course, but it's also the basis for how computers learn. Marv's next shift is at the Hexapawn chess booth. This will be his first time manning it, so he arrives early for training. Dot, who's pretty new to working the booth herself, will be training Marv. She invites him to play a friendly round to pick up the rules. The rules of Hexapawn are very similar to the rules of chess for pawns. Click the link below to read the rules or play the game to figure them out. Each pawn can move in these ways: forward one square if that square is unoccupied, diagonally forward if an enemy pawn is in that square. In that case, the enemy pawn is removed from the board. If you win, if you meet any of these goals. One of your pawns reaches the other side or the other end of the board. Your opponent's pawns are all gone, or after your move, your opponent has no available moves. Okay. Now that Marv has a handle on the rules, the real game begins. Dot is white, so she goes first. Help Marv play until he's won enough times to feel comfortable. Remember, Marv is playing as black. Play until it feels like you're winning most of the time. Okay. Okay, black wins. So obviously they are going to learn by the mistakes. So if we just keep doing the same thing, we will see them learning from the mistakes. Interesting. They're not going to make another move now because that would just be copying the same mistake that they made last time. So it looks like black wins every time. Let's try it one more time. Ah, they had a different opener that time. So there is a chance that there are different... No, there we go. So they're not going to play another move. Every single move or possibility has been played out and black has won every single time. So basically it's impossible for white to win if black plays the right moves. Okay. Your training isn't over yet. This time Marv is playing as white. Play the game repeatedly as Marv notes and play the game repeatedly as Marv and note how Dot's play changes as she starts to understand Marv's strategy. So I'm playing as white this time. After Marv and Dot have played many rounds, which player will be winning more consistently? Well, we've just figured out that black wins every time. So Marv is playing as white, so Dot will win every time. That's right, if you play enough rounds of Hexapawn against Dot, she will eventually learn how to win every time. But how is that possible? How is she learning? To understand, Marv has to win a round against Dot and then try doing the exact same sequence of moves again. Will Dot ever make the same mistake twice? Well, technically, no. Dot isn't just playing randomly. Even though she starts out that way, she's learning as she goes and won't make the same mistake twice. Dot learns from her mistakes. Let's see this in an example. Suppose this is the first time Marv has played against Dot, so she doesn't have any idea yet about how Marv plays. Let's say Marv starts by moving his centre pawn to the centre of the board. Okay. That leaves 4 possible moves for Dot. Which move is Dot most likely to choose? Remember that this is the first time Marv has played against Dot. So Dot hasn't got any prior knowledge of the game, and so she won't have anything to learn from, so all of these moves are equally likely. Let's say Dot decides to move one of her outer pawns forward. Okay. This would let Marv move his centre pawn diagonally, capturing Dot's other outer pawn and winning the game. Okay. Suppose Marv plays a second game and again starts by moving his centre pawn forward. Which move will Dot not make next? Well, A, because she will learn that she lost last time, so she won't do that. I've seen this board arrangement before. When I saw that board arrangement, I moved my right pawn forward, then I lost, or I then lost. So she knows not to make the same mistake again. Okay. That leaves 3 possible moves for Dot. Which move is Dot most likely to make next? Right. Right, okay. So in my opinion, there's 2 different answers here. It depends if Dot has got any knowledge of anything, or if she has no knowledge whatsoever of anything. Because if she had knowledge of symmetry, then she would know that moving D is exactly the same as moving A. And so she shouldn't do D, because that would be stupid. But that would be assuming that she had knowledge of symmetry. So, which move is Dot most likely to make? Well, obviously, we can't choose least likely. We have to choose most likely, and so the answer has to be all of these moves are equally likely. So we're obviously assuming that Dot has 0 knowledge of symmetry or any other knowledge in that regard. You might see that Dot moving her other outer pawn forward, i.e. move D, is just as bad mistake there. That's what I've just said. Dot doesn't understand that, since she's not reasoning about what might happen later. It's not about what might happen later, it's about symmetry. It's about the fact that it's the same move, but on the other side of the board, so it's not about what might happen later. But yeah, whatever. However you want to argue the point. So to know that a move is a bad choice, she needs to see a bad result. Not really, you just need to have knowledge of symmetry. But yeah, fair enough. So she'll randomly choose one. Let's say Dot chooses to move one of her outer pawns diagonally and capture the centre pawn. Will Dot go on to win? Maybe, maybe not, but Dot won't lose the exact same way she lost before. If you continue playing with Dot, she will eventually learn all the ways she can lose and will then avoid them. Okay. It turns out that in the game of Hexapawn, the second player can always win. Yeah, we figured that out. If they play cleverly enough. They just need to react correctly to the first player's move for a winning strategy. When you played Dot repeatedly, she used your own moves to decide how not to play. Eventually, she learns from her mistakes well enough to always win. Just like that, Marv's Hexapawn training is complete, but Hexapawn isn't the only game he needs to know to man the chess booth. Dot steps onto the booth and returns with a 4x4 version of the game. Dot sets up the pawns. She tells Marv to play as many rounds as he wants as black. Did Marv get to the point where Dot was always winning? Right, so we're gonna play some moves. So let's just copy exactly what she's doing. So white will always win if you copy the exact same thing. So let's copy the first move and the second move. Now they can take me there. So let's take her there and here and there and here. Okay, let's try that again. Right, so they can take me, so obviously I'll take that. Black wins again. I could actually just win immediately. Right, so it doesn't matter which one of these three I move, I'm going to get taken. So at least if I move that one, I could retake here. So we still don't really know if black wins every time yet. So let's just carry on playing a few more. Certainly feels like black is winning every time, but obviously that's because I'm choosing what to do. Right, okay. Well, here we go. White has won. Interesting. Okay. Right. Oops. Okay. So it's looking like white wins every time if they play correctly. So they're not getting to the point where dot is always winning, but I reckon if I kept playing, we would. Right, in the 4x4 game, white, the first player, has the advantage. What that means is that if both sides play as well as possible, white would win. Okay, so yeah, in a 4x4 board, it's reversed. That's what I expected. Marv wants to see this for himself. Play as Marv until you can play optimally as both black and white. Okay. Okay, so I have to move both pieces. Right. So that's obviously bad. Right. I can't remember what I just did there. Right, so black would win in this situation. Okay, so that is obviously not a good plan. So let's do two opposite sides. Yeah, black can't win. Okay, so if white goes forward on two opposite sides, they are guaranteed to win. Okay. So it'll take some time, but eventually Dot can learn how to win every time when she plays as white. Okay, fair enough. Right, that wasn't too challenging. Let's see what the next test brings. Okay, next up, androids. In logic, it's okay to assume something as long as you can come back and correct your assumption later if need be. In this lesson, you'll learn how to use assumptions to effectively solve problems and deduce the truth of the situation. The robots have received the boxes of clothes that Marv sent to them and have set up an impromptu Hall of Androids attraction for the guests. As Marv heads into the main hall, he realizes what's going on with his unofficial new attraction. There are more lying robots loose in the park, and they're trying to pass as humans to escape the park. This would be a disaster for his plans to show Evil Core HQ that robots, including Marv, are better than humans at running the theme park. Marv arrives at the first exhibit, Androids in the Office. He's going to ask some questions to identify the lying robots. He knows these. Human actors will only make true statements and androids will only lie. Okay. Bashir looks so real that Marv decides to assume he's a human even before hearing what he has to say. Okay, so if he's a human, right, let's read the rest. Does Marv's assumption lead to a contradiction? Okay, so if Bashir is a human, then Zoe is a human, then we're all humans, which Bashir is an android, so yeah, that's a contradiction. So Marv's assumption that Bashir is a human leads him down to this string of statements: human, 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 android. The first and last statements contradict each other since Bashir can't be both human and an android. What can we say on this contradiction? Bashir is actually an android. Bashir was an android after all. As it turns out, assumptions can be really useful as long as we come back and correct ourselves if need be later on. Now that Marv knows Bashir is an android, he can identify everybody else. Android, Zoe is a human, so that's a lie. Zoe is an android. We're all humans, that's a lie. Bashir is an android, that is true. Nice and easy. What if Marv had made two assumptions when solving a problem like this? What would a contradiction mean then? One assumption must be wrong, the other must be right, both assumptions must be wrong. We have no idea if one assumption's wrong or if both are wrong. That is correct. Okay, That's why making multiple assumptions can sometimes tell you less than making one assumption can. It's best to only make one assumption at a time if you can. Marv arrives at the next exhibit, Androids on a Monday. Everything looks to be in business as usual, but he's not buying it. Marv needs to identify every being as either human or an android. This time he decides to start by assuming that Vic is a human and will revise that assumption later if need be. Okay, Xander and Wes, or Wes, I think Wes, sounds like a German name. Xander and Wes are both humans. Okay, so if that was true, there is exactly one android. So Vic can't be telling the truth. So Vic has to be an android. Right. So Xander and Wes are both humans. So we need to change one of these. There is exactly one. Right. So if we need to change one of these, there's not exactly one. Oh. There's exactly one among the three of us, and it's not me. Right. Okay. Right. I'll come back to you. Vess is a human. So these would, if these are both human, then this is a lie. So, and if I change this, then this is wrong. So that would mean that there'd be 3 androids. Right, let's just check this. There's exactly 1 android among the 3 of us, and it's not me. Right, what is the difference between that and that? So this looks like it's right. Android, android, android. Because that's incorrect, so that's correct that it's a lie. That's incorrect, so that means that's correct because it's a lie. And that is incorrect, which means that is correct, so that's a lie. But if I change that to human, there is exactly 1 android. In a minute. There is exactly 1 android. And we've got 2 androids, so that has to be 3 androids. Haha, brilliant. Assuming Vic is a human was a good assumption for Marv to start with, since it allowed him to fill in a lot of the missing information and quickly reach a contradiction. When deciding what to assume, it can be helpful to look for a statement that fills in the most blanks at once, or many blanks at once, and is easy to test. Marv wanders into the exhibit, Androids discussing the weather. Which assumptions would be best for Marv to start with? Assume Ash is a human. Assume Bina is a human. Right, we need to read these. At least one of us is an android. At least one of us is human. Exactly 2 of us are androids. So, Chris then. Yes, assuming Chris's statement is true, let's Marv immediately say that the other 2 beings are androids, then look for a contradiction. Marv starts by assuming Chris is a human. What does he uncover about the beings at this exhibit? Exactly 2 of us are androids. Okay, at least one of us is an android. Well, if an android is saying that, then that can't be right. So either Ash or Chris is wrong. So that means Chris has to be wrong. So Chris is definitely an android. So let's uncheck these then. So exactly two of us are androids. So that means that I can't have exactly two of us androids if he is an android, because then that would mean he's telling the truth. So either all three of us are androids or these two are both human. So let's have a look. At least one of us is an android, correct. Him. At least one of us is a human, correct. Both of them. I believe that is the correct configuration. Happy days. Okay, in the next exhibit, Marv sees four beings playing shuffleboard. The first three beings vouch that each other being is a human. No one vouches that Gwen is a human, so Marv starts by assuming she is an android. Okay. What would that make everyone else? So at most, two of us are human, so that has to be a lie if she is an android. So that means that I need to have three or more humans, which means all three of these have to be human. That is Esther, that is Fitz, and that is Denali. Is that feels way too simple. Esther, Fitz, Denali, at most two of us is human. Is that? All right, happy days. That felt way too easy for this late on in the quiz. What if Marv had assumed Gwen to be human instead? What would this necessarily lead? Would this necessarily lead to a contradiction? Let's see. Okay. At most two of us are human. Well, it has to be a contradiction. Well, maybe not. Maybe not. Let's check. So most two of us are human. So that would mean either three androids or two humans and one android. So let's try two humans. So that can't be right because Denali is a human. That would lead to three humans. So now let's try three androids. So Denali is a human, which is a lie. Right, okay. I don't think it did lead to a contradiction, did it? Esther is a human, which is a lie. Yeah, so that's fine. Happy days. Okay, avoiding contradictions does not necessarily mean that your assumption was correct. There are two solutions to the last puzzle, depending on Gwen's identity. Denali, Esther, and Fitz are all human, Gwen is an android, or they're all androids and Gwen is a human. In both situations, Denali, Esther, and Fitz all share the same identity. Each of them also claimed one of the other two was a human, so that everyone is called a human by someone else. Could that be just a coincidence? Marv enters the next exhibit, Androids Living the High Life, where he sees a familiar face. When Gwen says Heidi is a human, what does that tell Marv? Okay, so when Gwen says Heidi is a human, what does that tell Marv? Well, Heidi hasn't said anything, so it's impossible to tell. It's impossible to tell because we've only got one piece of information. Isn't that correct? What? Okay, explain, please. If Gwen is telling the truth, then Heidi is also human. Oh my god. Just as Gwen claims, if Gwen is lying, then her claim is false. Heidi is an android. Okay, okay, I think I might have rushed that one a little bit. A bit of overconfidence going on there. Whoops. Okay, 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 okay. Let's slow down and double check everything from now on. If someone claims someone else is a human, they're both humans or they're both androids. Okay, okay, okay. In the next exhibit, Androids discussing modern art, Marv encounters the reverse. One of the art critics accuses another of being an android. What does this mean for their identities? Right. Okay. Right. So, at least one of them. Oh, Inamen. They're accusing them of being an android. So let's start here. Hal is an android. So let's say that Jing is human. Or should we start with the one that has got, there are exactly two androids. So there are exactly two androids. These two can be both androids, which means Kara is a human, so that can't be right. So Jing is a human, Hal is an android. Right, let's have a look at this. There are exactly two androids. Hal is an android, which is a lie, so that's correct. Kara is a human, which is a truth, so that's correct. And Jing is a human, which is a lie, so that is correct. Happy days. If one being claims another is a human, they are the same kind. That's only if they're Inamen. If one being claims another is an android, they're the opposite kinds. If one being claims that another is a human, they're the same kind. But, right, yeah, they're the same kind as. No, yeah, and if they're one, right, okay, okay, I'm understanding now. I'm understanding. So if they claim they're a human, they have to be the same kind, but they're not necessarily both human, they're just both the same kind. If one claims another is an android, they are opposite kinds. So it doesn't tell us what that person is, but it tells us that they're opposite. Okay, okay. Let's see if I can remember that. Finally, Marv can see a light at the end of the tunnel. He enters the last exhibit in this portion of the attraction. Can he sort through the madness and figure out who is who? Okay, Fitz is an android. Exactly two of us human. Fitz and Esther are both humans, or both androids. Gwen and Esther. So Fitz and Esther, Gwen and Esther, Heidi and Gwen. So let's start here. Let's say that Gwen and Esther are both humans or both androids. So let's assume they're both humans, which would mean Gwen, Esther, and this would mean Fitz and Esther. But it says here Fitz is an android, so let's try both androids, which means that these have to be a lie. Gwen and Esther. Right, let's see if we can work this out. Gwen and Esther are both androids. So Gwen and Esther, they have to be different for that to be true. So Fitz is an android. So let's change that. Exactly 2 of us are human. At the moment, that is true, and that's an android, so that's wrong. So we'd need Gwen to be human. Fitz and Esther are both humans. So Fitz and Esther. So this can't be true then. Right, so so let's swap these two around and see what we get to. Oh, have we just done this? Right, no, we haven't. So Gwen and Esther are both humans or both androids. Gwen and Esther. So Fitz is an android, which means Fitz is human. Exactly 2 of us are human. That's 3 humans. So this can't be. Ichabod can't be a human. It's impossible. So let's leave Ichabod as an android. Right. Let's start with Fitz. Exactly 2 of us are human. So if that is true, because we've established that these can't both be true, haven't we? Which means that I don't think exactly 2 of us are human can be true. So let's try Fitz is an android. Exactly 2 of us are human. Fitz and Esther are either both humans or both androids. Fitz and Esther, so that has to be a lie. Which means Gwen and Esther are both humans or both androids. Gwen and Esther. Right, I believe this is the answer. I'm not 100% sure, but I think so. God damn it. Right, so we've cocked up again somewhere. So let's go down. Fitz is an android. 2 of us. Oh no, that's where I've cocked up. Exactly 2 of us are human. So I need another human in here. So if we were going to put Gwen as a human, unless Heidi's an android, so I think both of these need to be. Oh, Inamin. Then that would make this statement true. Right. Exactly 2 of us are human. Right, let's try this. Oh my goodness gracious me. Fitz and Esther are both. Oh god, I didn't read it properly. Well, I haven't done very good on this test, have I? Oh, I seem to have lost the ability to click. Right, bear with me. Right, let's see if we can work this out now. Don't know why this is proving so challenging. Right, let's start at the top, even though I don't think that's the best place to start. So if someone's accusing someone of being an android, they have to be opposite to each other. Exactly two of us are human. That's not really helping us out, is it? Fitz and Esther are both... Ah, right, well, that has to be a lie. Right, okay, we've identified the problem. We know for a fact that Gwen is lying, because it's impossible for Fitz and Esther to be both telling the truth or both lying. So Gwen has to be an android. So if exactly two of us are human has to be a lie. Well, it doesn't have to be a lie because these can be the opposite way round. Which means these both have to be true. Gwen and Esther are both humans or both androids. So that's Gwen and Esther. So that is a lie as well, isn't it? Right, so I think that Fitz has to be the human then. And then Gwen and Esther are both human. In a minute, Heidi and Gwen are both human. So I think it's that. Heidi and Gwen are both. So Heidi and Gwen. That's a lie. Yep. Gwen and Esther. No. Oh, yeah. Two androids. Yep, that's true. Exactly two of us are human. That's true. Fitz is an android. That's a lie. I think we've got it. Hey. Oh dear. We made two mistakes there though. That wasn't good. Review and reflect. Not so good. Oh dear. That's the reflection. Oh well, I think we can do one more quiz and then I think I need to have a little rest. Right, next up, extrapolate. Solving puzzles with many moving parts can seem intimidating. In this lesson, you'll learn how to break down large problems into smaller ones. Marv stumbles into the next hall where there are three beings in the first exhibit. As before, androids always lie, humans always tell the truth. Identify everyone as a human or as an android. Okay. So exactly three of us, so let's choose Zither as the human. Exactly three of us are androids, so that's obviously not true. And if we do that, then... Right. So we need at least one of these to be human if we did this. Right. Only... So exactly one of us, it's the exactly part, so only one of these can be true. So that means there's only one human. If only one of them can be true because of the exactly, then it has to be just one person, so it has to be Xena. What? Have I done it the wrong way round? Oh god, I'm on a losing streak. I've done it the wrong flaming way round. I've done exactly one of us as a human. Oh god. Ah, I'm rushing today. I'm not checking my work. This is poor performance. So that means right, exactly two of us are androids. That isn't true. So does that mean they're all lying? No, because exactly 3 of us are androids. So exactly 2 of us are androids. Right, so is it the middle one? If 3 people are saying exactly, then it's the middle number. Yeah. Oh god, I can't believe I did it as exactly one of us is human instead of android. Okay, so if it was humans, it would be 1, the first one, or the one that says exactly 1. If it's androids, it's the middle number. So if there's 3 of them, then it's the second one. If there's 5 of them, it'd be the third one. But what about if there's an even number? That's a good one to try and figure out. So if there's two androids saying exactly one of us are an android, is there an answer to that? So if 2 of them are saying exactly one of us is an android, so the answer would be 1, because exactly one of us is an android. Yeah, so if it's an even number, it's 50%. So if it's 4 of them saying it, it would be 2. 2 of them saying it, it'd be 1. And then before, it was the middle one. So it's not 50%, but it's the median number. So 2 out of 3, 3 out of 5. So it's half and then rounded up. Half and then rounded up, right? So it's 50%. And if you get a non-round number, then you round it up. Okay, we figured it out. The next exhibit is bigger than anything Marv's seen in the Hall of Androids. There are 10 beings. And then exactly 1, exactly 2, exactly 3. Right, okay, pattern continues. Exactly 10. How many of the group are androids? So there's 10 people in the group. So half of 10 is 5. What? Oh god. Oh god. Oh god. I'm not reading the question. I'm not reading the question. Identify everyone as human. Exactly one of us is an android. How many are androids? Only one of them is human. So oh god, what am I doing? What am I doing? I'm doing exactly what I shouldn't do, and that is answering the question before I've read it. How many of the group are androids, not which one of the group is the human, which is what I basically just answered, the middle one. Oh god, what am I doing? So I basically chose 5 there because I didn't even read the question. I didn't even read the question. I basically just used what I'd learnt from here and imagined what the question would be. Oh dear, so I chose 5 because it was the 5th person that's the human. Oh god, what have I done? What have I done? This has been a disastrous string of answers that I've done. Okay, there were 3 beings. Right, let's go back up again and figure out. Let's do this properly. How many of the group are androids? I mean, unfortunately, we know the answer now. But we know the answer anyway. It's always all of them apart from 1. So it doesn't matter how many are saying exactly 1. If it says androids, then it's the middle one. What about if it says humans? That's a good thing to try and figure out. So if everybody was saying exactly one of us is a human, Exactly 2 of us are humans. Exactly 3 of us are humans. So only one of them can be true. So it'd have to be exactly one of us is human. So it's always the first one. So if it's human, it's always just exactly one. It's always one. If it's an android, it's 50%. The placement of the person. So when it says exactly, not 50% of them are androids, but the placement of the person saying it. Okay, right, okay. Let's read the question from now on, please. Stop rushing. There were 3 beings in the first puzzle and 10 in the second, but Marv could solve both with the same type of reasoning. Extrapolate. When solving a puzzle with lots of beings, think about how you might solve the same puzzle with fewer beings and then extrapolate. Okay. Right, let's read the question now, please. Marv enters another room with 4 beings. Each of them states that there are at least some number of androids. Okay. So this is different now because this is at least and not exactly. Identify everyone as a human or an android. Okay. Right. Identify everyone as a human or an android. So let's start with one human. At least one of us is an android. So at least 2 of us are androids. So if I went android, 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 then this has to be true. Human, sorry. At least 3 of us are androids. So yeah, it's half and half. 50%. So now let's assume that there's only 3 people saying this. So if there's only 3 people saying it, then at least 1, at least 2. So it's only 1 human if only 3 people are saying it. Oh, in a minute. Am I doing this wrong again? Am I doing it the opposite way? At least one of us is an android. I think I'm doing it the opposite way. Oh my goodness. Come on now. I don't know why my brain isn't working today. At least one of us is an android. At least 2 of us are androids. At least 3 of us are androids. At least 4 of us are androids. Okay, so they're definitely androids. They're definitely human. What I want to know is if there's only 3 people saying this, what is the answer? So at least one of us is an android. At least 2 of us. So let's just say he's an android. Right, I don't think you can answer it if there's 3 people saying it. Or at least this one isn't. Yeah, you can. I bet you can. At least 3 of us are androids. At least 2 of us are androids. So would it be human, android, human? At least one of us. At least no, because that's not true. So that has to be false. Which means that has to be human. Which means that isn't. No, that has to be true. I don't think there's an answer if there's only 3 people saying it then. We get a contradiction. At least one of us is an android. True. At least 2 of us are androids. False. then if you change it to Android, at least 2 of us are Androids, true. So we get a contradiction. We can't choose one of them if there's only 3 people all saying the same statement. Right, okay. Right, now Marv enters another room with 6 beings. Identify everyone as a human or as an android. Okay. So the last answer was, when there's 4 of them, 50% are human, 50% are android. And these are all saying at least again, and there are 6, so it's got to be 3 and 3. Do we trust, or do we try and double check? I'm gonna trust, even though I said I shouldn't. Hey! Right, have you noticed a pattern with the solutions? Yes, the next room contains 10 beings. The first one says at least one of us are androids. Okay, the next room contains 10 beings, so 5, because it's half in a min. Yeah, it's got to be 5 androids and 5 humans. Yeah, thank God for that. Right, Marv enters another room with 6 beings standing in a circle. Each of them accuses the being standing to their left and to their right. Find an arrangement with the largest possible number of androids, the largest possible. So let's start with everybody. Zed and Vera are both androids, right, so one of them needs to be human. So Zed and Vera are both androids, so Zed and Vera are both androids, so they have to be true. So let's now put Will at Vera and Xander are both androids. Right. So I could do that and that would be true. What about if I did that? So yeah, because you can break them down into triplets. Yuri, Zed and Vera, Xander, Willa and Yolanda. And then you'd have one of them true, the other 2 false. I think so. Ace. Right, Marv enters the next room where a group of 30 beings is standing in a circle. Each one accuses the beings to my left and right are both androids. What is the largest possible number of androids in the room? Well, we've just done this here. The largest possible number is 66%. So that is 20 out of 30, 2/3. Happy days. There can be no more than 20 androids in a group, but what is the smallest possible number of androids in the group? While Marv is pondering this, he goes back to the room with 6 androids. Find the smallest possible number of androids. Okay. So the smallest possible number of androids. So let's start with everybody as human then. Let's choose one android. I'm going to choose this one. Right. Yuri and Willa are both androids. Right, let's start with Yuri. Which means Zed has to be an android. So Zed and Vera are both androids. So I think it's 50%, isn't it? Zed and Vera are both androids, so yeah. Willa, Vera and Xander are both androids. So yeah, it's 50%. Great. Well, thinks he's found a pattern, so He returns to the room with 30 beings. Once again, the accusers say to the left and right of both androids, what is the smallest possible number? 50%. Happy days. Nice and easy. Made up for the ones that I've messed up on completely earlier on. Right, finally, Marv's seen all there is to see in the hull of androids, or so he thought. The hallway leads to the exit. That leads to the exit is lined with more human beings. Marv can't leave without correctly identifying all 42 of them. Fortunately, Marv finds another room with only 4 beings. In this room, he notices a pattern with the statements of the beings. Identify everyone as either android or human or android, assuming Ella is a human. So if we assume Ella is a human, Fatima is a human, George is an android, Heather is a human but is lying, so Heather has to be an android. Okay. Marv goes to another room with 6 beings. The statements of the beings in this room have the same pattern as the previous room. Okay. Marv goes to another room. Right. Identify everyone as either a human or an android, assuming Ella is a human. Okay. Fatima is a human. George is an android. Heather is a human, but because George is an android, it has to be a lie. Ian is an android, but because Heather is an android, Ian has to be human. Jorts is a human. Okay. Right, human, android, human, android, human. So basically, they're alternating their answers, but the answers themselves are double human, double android, double human. Right, okay. Marv is now ready for the line of 42 beings. He goes down the line getting the statements from each. First being says, the being behind me is human. So human, android, human, android. So we know that they're in pairs of double human, double android. If the first being is a human, right, so the first 2 are human, the next 2 are androids. If the first being is human, is the 42nd? Oh god. Right, okay. I'm just going to grab a piece of paper and a pen. It's probably a quick way to do this if I use maths. I'm either going to be lazy and just do it slowly, even though that makes no sense. So it's lazy in terms of not using maths, but more time consuming. Or I'll work it out with maths. Let's see. So first 2, so 1 and 2 are human. 3 and 4 are androids. So let's have a look what 11 and 12 and then 21 and 22 are. So 5 and 6 are human, 7 and 8 are android, 9 and 10 are human. Right, so that means that 21 and 22 are human, 31 and 32 are android, 41 and 42 are human. Hey, we got there. Fantastic. Correctly identified. The crowd disperses and Marv is finally able to relax. These lying robots won't ruin it for all the hard-working, well-meaning robots of the Evil Core theme park. Not if Marv has anything to say about it, and he does. Right, yeah, okay. So, I've made a lot of mistakes there, clearly. I was rushing through a lot of the questions. To be honest with you, I think I actually answered at least one of them, maybe even 2 of them, before I'd actually read the question fully in the first place. Really, I meant to read the question twice, and I don't even think I've finished the question once before I answered it. So, yeah, a lot of mistakes there, a lot of things to learn from, but still very enjoyable. So I hope you enjoyed it as well. And it's nice, nice to see some mistakes thrown in there from time to time. It just shows that you need to concentrate, double check, and just take your time. And unfortunately, my internet's gone down, but I was about to end the recording anyway. So I hope you enjoyed it. Cheers for watching. Take care, and I'll see you in the next one.